Hi everybody. Thank you for joining me for my presentation of my paper entitled Implicit Bias in STEM Fields. This paper was the result of some work that I had done earlier in the semester with a group of people here at Northwest College. We had a research team that was involved in a Perkins-funded research project for an organization called NAEP. And NAEP is, pull this up a little bit so you can see it. NAEP is the National Alliance for Partnership in Equity. And basically, NAEP's focus is to talk about areas where underrepresented groups can achieve more equity through action projects. So the group that I worked with here at Northwest College was a Perkins-funded group, and it was a combination of people in several different programs, some 2-year programs and some 4-year programs that we have here at the college that are Perkins funding eligible. So we had representatives from engineering, welding, photography, drafting, and then we had some administrators in advising and one of our deans as well. So as we talked in this group, we met once in Casper and once in Riverton, and we're going to be meeting again in Casper in the middle of May. But basically, the problem that was presented to us was to find one area of inequity in our college, in one of our programs, and to develop an action plan to try to increase equity in that program. So as a group, we chose women in engineering and implicit bias toward women in engineering. So the first thing we did, we looked at registration records of engineering majors at Northwest College, and we found that we have 42 people who have declared engineering as a major, but only 2 of them are women. So we realized that our subset of women in engineering at Northwest College was really too small to study in specific, and so we decided that we would go broader and take a look at some of the ways in which men and women differed in terms of their approach and their feelings about engineering. So we developed a survey, and that survey asked several questions about how, not about ability in engineering so much, but in terms of what your attitudes are toward engineering. So the first question you'll see, we have how strongly do you associate males and females with each of these areas, the third of which is engineering. So some of these fields are compared to engineering. I mean, like spatial reasoning and math tend to go hand in hand with engineering. Others are very different. So we asked, how strongly do you associate these following with males and females? How interested are you in these areas? Do you agree or disagree with these statements? This has to do with workplace environment. And this also has to do with working with predominantly male or predominantly female groups. Then also perceived expectation of success, or really this is efficacy, which is sort of more or less defined as being how well you think you'll do in a particular task-based situation, rather than just having confidence in your overall ability. Specifically, how do you think you would be in these areas? And we did some demographic stuff. What were your grades in classes? What's your age? What gender do you identify with? This, the gender question is binary. We didn't leave room for any intersex or other answers besides just male and female. And then we asked about the statement which best describes your major, how long you live in the Bighorn Basin, and then if they're students at Northwest College, how many credits do you usually take in a semester, and some things about your family of origin, your mother's education and your father's education, and also just sort of general familiarity with the field of engineering. So our method was to generate this survey, and we distributed it first to Northwest College students. We got 106 responses. One of the things you may have noticed on the survey, though, we didn't really have a neutral response. The Likert scale lacked an item centered at neither male or female, and so for the purposes of this class, I used the same questions, but I rewrote the scale so that each one of them contained a neutral response. So what we actually distributed was the second survey. And the second survey we distributed to Northwest College students, but we only got about 15 responses. And I attribute that probably to survey fatigue, or perhaps because the questions were the same, the students may have felt that they had already responded to this survey. So I had to go a little farther afield, and I posted it to my personal Facebook page, where most of my colleagues are educated women over the age of 40. So you'll see that my demographic has skewed quite significantly toward that group. So the first thing I wanted to do were some ANOVA comparisons. And I really focused on the second question about engineering. In other words, how strongly do you associate engineering with males and females? And what I found was, I'm going to hide my face here so that you can just see the rest of the screen, that for all respondents, the mean was 2.41, which means slightly skewed toward, or slightly oriented toward male, more associated with males. A standard deviation of 1.05 with 71 full-on respondents. By age group, you can see that the mean breaks down. The skew gets a little bit more centric. In other words, less male-oriented, more oriented toward the middle as the age groups get a little bit older. For my ANOVA results on these comparisons, which I have an F of 0.32 and a P that was much greater than 0.05, and an eta squared of 0.02, which indicates a very small effect size. Actually, about 2% of the effect came from the age. So basically, we cannot reject the null hypothesis. Now, the next time I did the same comparison, I took the question, how strongly do you associate engineering with males and females? This time I sorted it by gender. And once again, you can see that females associate it less strongly with being males, with being a male-oriented profession than do men. However, my eta square is still extremely small, and my P is greater than 0.05. So the results are not statistically significant. So I cannot reject the null. Now, I need to apologize to Jenny here, because in my methods paper, I stated that this was a significant, there were some significant results. And to be honest with you, I don't even know what I was looking at, because I've gone back through the pages and pages of ANOVA testing that I've done, and I can't even find it. So so this is the part that will go into my, these are the results that will go into my actual paper, and the other was, I don't even know what it was. So moving forward, I then sorted to see maybe years, we live in this very rural community where engineering is not a visible profession. So is there more of a bias based on the number of years that a person has lived here in Wyoming's Bighorn Basin? And once again, the answer is no. Very small effect size and very large p-values. So we cannot reject the null hypothesis. So overall, my ANOVA test showed no differences at all. I then decided to do a couple of ANCOVAs where I held a covariate. I took the same question, and I decided maybe this is different if the respondent is a STEM major or a non-STEM major. So I looked at the independent variable, as which gender do you identify as. So I'm breaking it down by males and females. My dependent variable, how strongly do you associate engineering with males and females? And as I said before, I had looked at that comparison before in ANOVA, but I used as a covariate major, because I've broken that down into a science major or a non-science major. And my first ANCOVA results, same thing. Very small F value, very large P, very small eta squared, indicating that we have a small effect size, almost no difference based on that covariate. So for my second ANCOVA, I wanted to do a factorial, and I played a little bit with this, but I wanted to pull into this ANCOVA. I wanted to use as my covariate both how successful do you think you would be in engineering and how interested you are in engineering. So using this success factor, I found again that I did not have any significant results. So again, I cannot reject the null hypothesis. Well, after that happened and I had 5 runs of insignificant results, I asked myself, what would significant results look like for this test? So I went back to the survey, and although this does not have a great deal of research applicability, I decided that I would take 2 questions that I felt would be strongly correlated with each other. How interested are you in engineering, and how successful do you think you would be in engineering? And so since they were on the same scale, I did not have to reverse the scale, and because 1 would be low, either not successful or not interested, 5 would be high, very interested or highly successful. And when I ran the ANOVA with those 2 variables, what I did find was that this was significant, that my F value is 27.95, my P value is less than 0.05, and my partial eta square is 57%, or 0.57, meaning that about 57% was due to the fixed factor. So at least I got some significant results. Thank you for watching my presentation. Please, I'm here in real time, so let me know if you have any questions. Thanks.